So there are a couple different ways to do these problems. In the notes, we did a lot of like the sine squared plus cosine squared equals 1, like that set of formulas. I think 1, 2, and 3 are actually easiest if we do them kind of like we did them in chapter 12 by setting up triangles. And so we did that a little bit in class when we were doing chapter 13, or section 13.1. So number 1, I tell you that cotangent is 1 over 2. And then I tell you that theta is somewhere between 0 and 90. So by telling you that, I'm telling you the quadrant. So for 1, 2, and 3, I'm always going to tell you the quadrant that the angle's in. So 0 to 90 is just the first quadrant. So I want you guys giving yourself this nice visual of what an angle would look like in the first quadrant. And I mean, I always tend to just draw what looks like a 45-degree angle. It's not going to necessarily be a 45-degree angle. But you just sketch in that angle somewhere in the first quadrant. The angle should always be made with the x-axis, never with the y-axis. So you would always put it here, never here. Okay, so then you just make a little triangle in that first quadrant. And so what cotangent is giving you, it's giving you 2 of the 3 sides. So whether I give you sine, cosine, tangent, cosecant, secant, cotangent, whichever of the 6 that I give you, I'm giving you 2 of either opposite, adjacent, or hypotenuse. So cotangent's a little bit tricky. One easy way to do this is to flip to its reciprocal, because if you think like SOHCAHTOA, that's just sine, cosine, and tangent. What's the reciprocal of cotangent? Which one of those 3? Tangent. Yeah, so cotangent goes with tangent. So if you know that cotangent is 1 over 2, that automatically means that tangent is 2 over 1. So it might be easier to deal with it that way, because a lot of times we know sine, cosine, and tangent a lot better than the other 3. So you can just flip it just as easily and say like, okay, that must mean that tangent is 2 over 1. So if we know tangent, what's the formula? I think SOHCAHTOA. Like opposite, hypotenuse, adjacent, using all those. Good. Tangent is opposite over adjacent. Okay, so that means we know the opposite side for this angle and we know the adjacent side for this angle. So you can label those right on there. So opposite over adjacent. Opposite the angle would be this one. We label it with a 2. And then adjacent to the angle would be this one, and we label it with a 1. Okay, you could also figure out that cotangent must be adjacent over opposite, because you know that it's the reciprocal of tangent. So you could say like this would be adjacent over opposite, and you'd end up labeling them the exact same way. Some people just find it's easier to flip to tangent. Okay, so then we need this missing piece, which we find by doing what? Pythagorean theorem. Good, so make sure you're plugging everything into the right spot. Here it's the hypotenuse that's missing, so make sure you're leaving the hypotenuse as the variable. So a squared plus b squared, we'd have 1 squared plus 2 squared equals c squared. And you can find your missing piece. Okay, so add these together, we get 5, and then that's equal to c squared. So when you take a square root, all of your directions throughout this whole practice test and throughout your whole test will say give exact values. Exact values are not decimals, so you really shouldn't have decimals for any of these questions. So when it says square root of 5, you want to actually leave it as the square root of 5, because that's an exact answer. If you did a decimal, that would be an approximation. Yes? So you will do a plus or minus. We'll talk more as we move, like 2 and 3 will move us into different quadrants. So if we're in the first quadrant, all of these measurements are automatically positive because everything in the first quadrant is positive. But yeah, we'll talk plus or minus with 2 and 3 especially because they put us into different quadrants. Okay, so to actually answer the question, like this is the hard part. This takes most of the time is doing all this. Then we're being asked for sine. And so sine, as we know from chapter 12, is opposite over hypotenuse. So once everything's all set up and labeled, you just grab the opposite and the hypotenuse and just set it up. So opposite of that angle would be the 2, and then the hypotenuse would be the square root of 5. So leave it like that if you want to. I've told you I don't care if you rationalize the denominator. If you do rationalize the denominator, you'd be multiplying by square root of 5 over square root of 5, and you'd get that. Either one of these answers is totally fine. What I don't want is a decimal, because like I said, use exact values, so you should not be typing those in and get a decimal. Just leave it exactly the way it is. Okay, so let's do number 2. Same sort of technique. So this one, I tell you that cosecant of the angle is -3/2. So we've got that. And then I tell you that the angle is between 180 and 270. Okay, so this is 180, 270, so the angle is somewhere in there. And remember, make sure your angle always goes to the x-axis, not to the y-axis. And then we can make a little triangle out of that. So cosecant. We need to figure out which two of the signs it gives us. It either gives us the adjacent or the opposite or the hypotenuse. It'll give us two of those. And we're not as familiar with cosecant, so we can flip it. What's the reciprocal of cosecant? Which one? We should know these, guys. We had all of chapter 12. Reciprocal of cosecant. Sine. Good. So if we flip, it means that we know that sine is negative 2/3. So it might be a little bit easier to work with that because we know what sine is. So SOHCAHTOA says that sine is opposite over hypotenuse. So we can label those two. But you could also just leave the cosecant. If you know that cosecant is the reciprocal, that just means it's hypotenuse over opposite. So you end up labeling the sides correctly either way. So if you want to ask about sines, that's exactly why I give you guys a different quadrant, because the signs could change as you're moving around. So here in the third quadrant, this measurement right here is going to be negative because it represents the x value, and the x value would be negative if you're in the third quadrant. And then this measurement right here is also going to be negative because it represents the y value, which is negative in the third quadrant. This diagonal right here, it represents the hypotenuse. It's always positive. It doesn't matter what quadrant I place you in. This diagonal right here is always going to be positive because it represents a distance rather than an x coordinate or a y coordinate. X and y coordinates can be negative, and they will be, depending on what quadrant I put you in, but the distance from here to here is always something positive. Question?
Oh, why is this in the third quadrant, not the second quadrant?
180 to 270 was given for number 2, so that's 180 and that's 270. Okay, so we're going to label the pieces that we've got. So sine, the opposite would be -2. So opposite this angle would be this right here. And the reason it's labeled as a negative is because it represents a y value, and y values are negative. And then hypotenuse would be 3, and hypotenuse is always positive, always, no matter what quadrant you're in. Okay, so now we're going to find that missing piece. Careful with your formula. That missing piece is one of the legs, so make sure you use either a or b in your formula. So we've got a squared plus, so b squared would be the other leg. If I square this, I get +4. Not -4, but +4. Equals c squared, which is 9. And this 1, 2, and 3, this was a total accident, but the square root of 5 ends up being all of these missing pieces. Definitely didn't do that on purpose, and it's not a pattern that you should look too far into. But this, subtracting the 4, we end up with 5. So this one, when you square root, remember, when you're square rooting, you technically have a plus or minus, and it depends on which quadrant you're in. Okay, so here, this length right here is either the positive square root of 5 or the negative square root of 5. Which one would it be for this quadrant? Negative square root of 5. Good, so keep the negative because it represents the x value, which is negative there. Yes, ma'am?
So if we do plus or minus, like we make it wrong?
You can write plus or minus, like if you did it in this step, if you said like, oh, it could be positive or negative, but you have to decide on one or the other for your final answer. Okay, so we've got everything labeled, and number 2 is asking for cotangent. So cotangent, we talked about that with number 1. It's adjacent over opposite because it's the reciprocal of tangent. So the adjacent side would be this one right here, which is the negative square root of 5. And then the opposite side would be the -2. Remember, no decimals, but we do want to simplify this up just a little bit and make sure that it's just positive over positive because we had a negative over a negative. Mm-hmm. It's not reduced if you leave it, because that'd be like leaving it, 2/2 or something like that. So yeah, make sure that is reduced. Okay, so number 3, last one of this type. I gave you tangent of theta is -1/2, and then said 270 to 360. So 270 to 360 would be the fourth quadrant. So here's 270, here's 360. So put your angle somewhere in there. And again, make sure the angle is made with the x-axis, not with the y-axis. Okay, so tangent. If you think SOHCAHTOA, tangent is opposite over adjacent. One of them is negative, but not both. Which one is the negative one, the opposite or the adjacent? The opposite would be the negative one, because here the opposite represents the y value, and the y value is the one that would be negative for the fourth quadrant. And the adjacent is a positive 2. So it could be, if you think of negative 1/2 could be negative 1 over positive 2 or positive 1 over negative 2. So it's up to you to know which one it is, depending on which quadrant I give you. So here the y value would be the negative 1, and the x would be positive. So we need the hypotenuse. So we have a squared, which would be 4, plus b squared, which is positive 1, not negative 1, equals c squared. And again, see, they accidentally all came out to be the square root of 5, which was not on purpose. So this we've got square root of 5. So remember, it could be plus or minus. This one, it's the hypotenuse, and the hypotenuse is always positive because the hypotenuse represents a distance, not an x or y value. The distance is always positive. So you've got root 5, no decimals. Leave it as the square root of 5. And in number 3, I asked you for sine. Okay, so sine is opposite over hypotenuse. So the opposite of the angle would be negative 1. And then the hypotenuse would be the square root of 5. So leave it like this if you don't want to rationalize. If you prefer to rationalize, you would multiply by the square root of 5 over the square root of 5. Remember, either of these answers is fine. A decimal is not. Okay, so all of these are the same type of problem. You guys will have one of these tomorrow. Well, I give you one of the 6 trig functions, one of the 4 quadrants, and then ask you for another one. So you're doing this. Any questions on that? Okay, the next set, 4, 5, and 6 were all verifying identities, and that was all from 13.2. So let's go through some of these. Okay. All right, so these ones, you pick a side to start with, and it'll usually be fairly obvious which side is the more complicated side. So you start with one side, and then you just simplify it until you can get the 2 sides to match. Okay, so work one side at a time. We're going to start with the left-hand side because the right-hand side is simpler, and it's already in terms of sine and cosine. So I have just a list of all the formulas that you guys have in your notes that I'm going to keep putting up on the screen so you can see them. So tangent, you want to use this formula right here. Tangent, we also have 1 over cotangent, but that won't do you any good here. It'll be just as complicated. So with tangent, you want to rewrite it as sine over cosine. So anytime tangent pops up, rewrite it as sine over cosine. That'd be your first move on our left-hand side here. And then the 1 minus sine squared, this is something that you guys have seen a number of times last week and probably the week before. You guys should recognize this one. The sine squared plus cosine squared equals 1. That's your Pythagorean identity. But then we took it and we first solved it for sine squared, getting sine squared by itself. And then we got cosine squared by itself, and it gave us these 2 other options over here, which is just the same identity, just rearranged a little bit. So we're going to use this top one right here. So we have a 1 minus sine squared. This tells us that we can replace it with cosine squared. So that's what we're going to do. Okay, so replace this right here with cosine squared. Okay, and then I'm not touching the right-hand side. I'm just leaving it exactly the way it is until I'm done with the left-hand side. Okay, so if you think of this as like over 1, this is being multiplied together so you can cross cancel, and you'll see that we have cosine squared in this numerator and then cosine in this denominator, so you can cancel one copy out. So this copy in the denominator will cancel with one of these copies, and then it'll leave you with just one copy. So the left-hand side is now sine times cosine, which is exactly what we started with on the right-hand side. So this problem is done once the left matches the right. And remember, I always just kind of put a check mark like, yep, it's verified, we did it. Okay, number 5, some different properties. We've got cosecant over secant is supposed to come out to be cotangent. So this side, or this one, neither side is in terms of sine or cosine. So we're going to want to put them both in terms of sine and cosine. So let's start with the left. It's a little bit more complicated. So we've got these formulas that I would make sure you guys have in your note card. These are from 13.1. Cosecant is the reciprocal of sine. We know that. And then secant is the reciprocal of cosine. So I'm going to rewrite both of these two on the left-hand side. So cosecant is the reciprocal of sine over, and then secant is the reciprocal of cosine. So we're focusing all our energy on that left-hand side until we're done with it. And remember, fractions divided by fractions, what we do is we take the numerator, and then instead of trying to divide by a fraction, we're going to multiply by the reciprocal. So instead of dividing by 1 over cosine, we're going to multiply by cosine over 1. And then again, not touching that right-hand side until we're done with the left-hand side. So left-hand side, when you're multiplying fractions, numerator is just 1 times cosine, and then the denominator is just sine times 1. So we get that. So I would say that we've now taken that left-hand side as far as we can, because we've got it in terms of sine and cosine. It's completely reduced. So now if we look at this right-hand side, we can take this property right here from 13.1. It's a quotient property. Cotangent is cosine over sine. So if we replace the right-hand side with cosine over sine, then they'll match perfectly. So the left-hand side was already cosine over sine. And then I'm just going to use this property to replace my right-hand side with cosine over sine. And as soon as we do that, then the two sides match perfectly, which means we're done. You could have also replaced this left-hand side with cotangent, and then you would have had cotangent equals cotangent, which is fine. So these verifying properties, you've got different pathways that could get you there, but as long as the left-hand side comes out equal to the right-hand side, then you're good. Okay, number 6, we've got sine squared plus cosine squared over cosine squared. Okay, so this is what we're starting with. Left-hand side, definitely more complicated than the right-hand side, so we're going to start there. So left-hand side, you should recognize this property in the numerator. Okay, we've got the property that says that sine squared plus cosine squared is equal to 1. So when we have that in the numerator right here, we're just going to replace it with a 1. And then that's about as far as we can take that left-hand side, because we simplified it up. It's in terms of sine and cosine. And if we look at the right-hand side now, the right-hand side we've got a secant squared. So you can see this property right here tells us that secant is 1 over cosine. So if I square the secant, that just means that I square the right-hand side as well. Okay, so if I square the right-hand side, I have 1 squared over cosine squared. So my right-hand side, I'm writing as the reciprocal of cosine, and the left-hand side already was the reciprocal of cosine. So as soon as I do that, then the two sides are equal. Okay, so that was 4, 5, 6. That was 13.2. So those are your different properties, verifying, writing things in terms of sine and cosine. Our next 3, 7, 8, 9, are all of our sum and difference formulas. So you guys have a list of 6 of these different identities. They're all in your notes. I would make sure that each one of these is on your note card. So for number 7, and I'll give you guys the same instructions as I did with 7 and 8, where I tell you, like, use a sum and difference formula, so that way you have a little clue. So use the sum and difference formula to find the cosine of 75 degrees. Okay, so normally if I ask for a cosine, it comes off the unit circle, but this one is not on the unit circle. 75 degrees, we go 30, 45, 60, and then right to 90. So 75 is not on our unit circle. But what we can do is write it as the cosine of, and then instead of 75, write something plus something. So what would we fill in there? How can we add up to 75? Yeah, 30 plus 45, good. So 30 is a unit circle value, 45 is a unit circle value. So we've got this second formula right here is the cosine of A plus B. So we're just going to make little substitutions. A is now 30 degrees. B is now 45 degrees. So we're going to sub just into this formula right here. The A's will be replaced with 30 degrees. The B's will be replaced with 45 degrees. So we have cosine of A, which is 30 degrees, times cosine of B, which is 45 degrees, and then minus sine of A, which is 30 degrees, times the sine of B, which is 45 degrees. Okay, so you guys will have those formulas on your note card. I forgot to mention everyone gets a note card even if at some point you lost any points along the way, because this, without a note card, without all these formulas, I would just be setting you up for failure. So everyone gets a note card. Make sure it has a unit circle on it as well, and you will see why as we finish up this problem, because we're going to have to pull all of these values off the unit circle. I will not be providing you with anything tomorrow, so make sure you've got your formulas on the note card, unit circle on the note card. So this one, cosine of 30 degrees and sine of 30 degrees. Let's start there. So on our unit circle, we find 30 degrees, which is right here. And remember these ordered pairs on the outside, the x is cosine and the y is sine. So we're gonna pull those values right off. So cosine of 30 degrees is the square root of 3 over 2. And the sine of 30 degrees is 1/2. Okay, so I'm just pulling these values one at a time off the unit circle. And then for 45 degrees, I repeat that process. Here's 45 degrees. Cosine is the x value, which is the square root of 2 over 2, and sine is the y value, which is actually the same. So cosine of 45 degrees, the square root of 2 over 2, and sine of 45 degrees is also the square root of 2 over 2. So those values are getting pulled right off the unit circle. You want to make sure that you have a unit circle on your note card tomorrow. And you can, if you want to print a tiny little one out and tape it on, that's fine. Just make sure you've got it on there. So these ones, when you're multiplying these two together, square roots can be multiplied. You multiply the 3 times 2, you get 6, so this just becomes the square root of 6. So you can multiply square roots, and the denominator would just be 4, 2 times 2. Minus, and then here you have 1 times the square root of 2, which is the square root of 2 over 4. So these ones, 2 really important things. Number 1, I just mentioned that you can multiply square roots. You cannot subtract or add square roots. So you can't make this into the square root of 4. It is not the same as the square root of 4. So you literally just leave them separate. They're not like terms. You can't add or subtract them. So you just write them like this. And you leave it like that. This is the second thing. You leave it like that because number 7 specifically asked you for an exact value. So you shouldn't be plugging it into your calculator. You shouldn't be getting a decimal. You would leave it just like that. That's an exact value with the fractions and the square roots and all that good stuff. Okay, so now number 8, very similar. This time it's asking you for the sine of negative 165 degrees. So 165 degrees is not on the unit circle, so neither is negative 165. So did anyone find a way to set this up using either addition or subtraction? Negative 165, yeah. Perfect. 45 minus 210. So we'll write this as sine of 45 minus 210. I also heard this morning 60 minus 225. That works as well. There's a couple different ways that you could set these up. Your answers will all turn out the same even if the process isn't identical. Okay, so we've got our formulas. So we have our subtraction formula right here that you would have on your note card. So sine of a minus b, so that just means the a's become 45 degrees and the b's become 210 degrees. Not negative 210. This is already subtraction, which means that the subtraction is already accounted for. You don't have to make it negative. Okay, so this we've got sine of 45 degrees and then cosine of b, be cosine of 210, minus cosine of A, which is 45 degrees, and then the sine of B, which is 210. So just pulling right off of that value, right off of those formulas that you've got. And then once you have the formula all written out, that's when you pull from the unit circle. So that's why you need to make sure you've got a copy of that. So 45 degrees is our first angle here. So here's the 45 degrees. Sine of 45 degrees is the first one we need. That's the square root of 2 over 2. So that's this value right here. And then cosine of 45 degrees is also the square root of 2 over 2. And then our formula has subtraction, so I want to make sure I keep that there. Okay, so pull those two values off. 210 is down here in the third quadrant. So cosine of 210 is the x value here, which is negative square root of 3 over 2. And then the sine of 210 is the y value, which is negative 1/2. Okay, so make sure that you know how to pull those values right off the unit circle. And then once they're there, you're just simplifying. You're multiplying, you're subtracting. Yes, ma'am.
So since you put the subtraction sign outside the cosine 45, does that mean the
Well, yeah, sine of 2 theta is positive, and it's all just part of this formula. This formula has subtraction. It wasn't anything that I did myself. It's just coming from the formula. Okay, so multiply these. Remember, square roots can multiply. So you've got negative square root of 6. The denominator is 4, just 2 times 2. And then minus, and then multiply these two together. So root 2 times negative 1 would be negative root 2, and then over 4. So first thing, the minus negative would change to plus a positive. And remember, if square roots are not the same, you cannot add them. You cannot subtract them. So this, we just combine them over a common denominator, and you just leave it like this. So these types of questions should have those very strange looking answers. Fractions with square roots inside. Make sure you actually leave them like that and don't give me decimals. Okay, so you'll have one like 7 or 8, and then you'll have one like number 9 where you're verifying an identity. So number 9 was also using a sum or difference formula. And I think I actually wrote like use a sum or difference formula to verify this identity. So this one, for number 9, you would use the sign with the addition. So we're going to start with this left-hand side because that's the more complicated side. So we're going to sub it into this formula right here. So the A's become 360 degrees, and then the B, you just replace it with a theta. Okay, so we're going to sub into this formula right here. So sine of A, you would write sine of 360. Cosine of B would just be cosine of theta. And then plus cosine of A would be cosine of 360 times sine of B. That's the sine of theta. So that's the left-hand side. That's what the left-hand side started off as, and then I plugged it into the formula. The right-hand side is just sine theta. I am not going to touch that right-hand side. I'm just going to keep simplifying the left-hand side until it's also sine theta. Okay, so this value and this value would come right off the unit circle. Sine of 360, cosine of 360. So this 360 is the same spot as 0. It's the beginning of the circle, but after you go once around, it's also the end of the circle. And this one that I printed out doesn't have the 360 on it, but the one that you have in your notes does. So first thing we need is sine of 360. So here's 360. The y value is 0. So sine of 360 would be 0. So we have 0 times. And then for cosine of theta, if you don't know what theta is, you just leave it like that. So just leave it as cosine of theta. And then plus cosine of 360. Here's your 360. And remember, cosine is the x value. So we take 1. And then with sine of theta, same thing. We don't know what theta is. So you just leave it like that. It's like a variable. And then I'm not touching the right-hand side. I'm just hoping the left-hand side comes out equal. So what is 0 times cosine? 0. So this term's gone. That's just 0. And what is 1 times sine? Sine. Good. So the left-hand side did actually turn out to be sine, and so it matches with the right-hand side. And that's what means you're verified when they come out to be the same. Okay, so 7, 8, 9 are your 13-3 problems. You'll have one like 7 or 8, and you'll have one like 9. Okay, so then 10, 11, and 12, these are your double angle formulas and half angle formulas. So with number 10, I had you doing all 4. You'll have a problem where I just ask you for one of the 4, and then another problem where I just ask you for one of the 4. You won't have a huge, bulky problem like this. So number 10, I give you that sine of theta is 8/17, and then I tell you that we're working between 90 and 180. So 90 starts quadrant 2, and then it ends with 180. So it's somewhere in this second quadrant right here. So draw your angle wherever in quadrant 2. Make sure your angle is made with the x-axis, not with the y-axis. And then we make a little triangle out of it. So this is actually, this first part is just like examples 1, 2, and 3. Okay, so you set up your little triangle, find the missing piece. So sine is opposite over hypotenuse. So the opposite to this angle would be where the 8 goes. And then the hypotenuse is the diagonal, and that's the 17. Okay, so just exactly like we did with 1, 2, and 3, you guys have got to find that missing piece. So our missing piece, we have a squared, that's what we're trying to find, plus b squared. So when I square the 8, I get 64 equals c squared. And when I square the 17, I get 289. Okay, so to solve for a, subtract the 64 from both sides. 289 minus 64 is 225. And square root both sides. So a could be 15, but it could also be negative 15. Pay attention to the quadrant that you're in. Which one is it? It's the negative 15. Good. Because this represents the x value, and if you're going to the left, you would have negative x values in the second quadrant. Okay, so you are currently being asked for all of these formulas right here. This one, this one, this one, and this one. All of them need cosine. Okay, so your next step would be to figure out what cosine is, and then you basically just start subbing things into these formulas. So cosine of theta. Cosine has always been adjacent over hypotenuse. Adjacent would be the negative 15 that we just found, and hypotenuse is the 17. So make sure you're correct on that sign, because if you have positive instead of negative, it's going to slightly throw off every single one of these formulas. Okay, so first one that I asked you for was sine of 2 theta. So we're just going to follow this formula right here. You guys would have that on your note card. So it's 2 times whatever sine is, and that was given to you. It's 8 17ths. And then cosine is the one that we just found, which is negative 15 17ths. Okay, so you're just multiplying 3 fractions. So think of 2 as like 2 over 1, so it makes it a little easier to multiply. So multiply the numerators. 2 times 8 times negative 15 comes out to be negative 240. And then multiply the denominators. 1 times 17 times 17 comes out to be 289. So that would be your first answer. And like I said, your questions tomorrow, you'll only be doing one of these 4, but I just wanted you to practice all 4 of them because I'm not going to tell you which ones you'll be using. Okay, and then next one, cosine of 2 theta. So that would be this formula right here. So first part is cosine squared. So we plug in cosine and then square it. And then the next part is minus sine squared. So minus, and then we plug that value of sine in and square it. Okay, so when I square this, remember, even though I'm squaring a negative, it comes back positive. So when I square negative 15, I get 225. And when I square 17, I get 289. Minus, and then square this. When I square the 8, I get 64. And when I square the 17, I get 289. So they have the same denominator. So we just subtract 225 minus 64, and that leaves you with 161 over your common denominator. Okay, so you leave them. Both of them you leave like that. Fractions, not decimals, because fractions are exact answers, decimals are approximations. And your directions all say to give an exact answer. Okay, so now we move on to this next one, sine of theta over 2. Okay, so we've got plus or minus, and we'll talk in just a second about how to choose plus or minus. Big square root, and you have 1 minus cosine, which is negative 15 17ths over 2. Okay, so you're just plugging values in right off of that formula. Okay, so let's talk plus or minus first. So they gave us something about theta. Okay, they told us that theta was in the second quadrant, which is somewhere between 90 and 180. And then they're looking for theta over 2, which is half of theta. Okay, so they're asking about half of theta. They told us that theta was somewhere between 90 and 180. So here's what you would see on the test. So theta, original theta is somewhere between 90 and 180, right? That's why we sketched in the second quadrant. If we're taking theta and dividing it by 2, that means we're dividing 90 by 2 and we're dividing 180 by 2. So that tells us where half of theta is going to end up. So half of theta is going to end up somewhere between 45 and 90, if I cut these 2 in half as well. Okay, so half of theta will end up somewhere between 45 and 90, which is where? What quadrant? First quadrant. Good, so 45 to 90 would just be in the first quadrant. So if I'm in the first quadrant, would sine be positive or negative? Positive, good. Sine is positive in the first quadrant. So I know it's going to be the positive one. So let's then jump back in here. So first the minus negative changes to plus to positive. And then with these, when you have these fractions inside of fractions, you're going to take top and bottom and multiply it by whatever this denominator is to clear out the fractions. So that denominator is 17, so we're going to multiply top and bottom by 17. Okay, so make sure you multiply everything by 17. So 1 times 17 is 17 plus, and then this is the part that people mess up, 15/17 times 17 is just 15, because these 17s would end up canceling each other out. So then all you'd have is the 15. And then in the denominator, 2 times 17 is 34. Okay, so I'm not going to keep writing the plus because we just assume that it's positive if I don't write that it's negative. So we get 32 over 34. And I can reduce that. 32 over 34 is 16 over 17. And then for my final answer, I can take the square root of 16, so I'm going to do that. So the square root of 16 is 4. And then the square root of 17, you can leave it if you want. You can rationalize the denominator if you want. Either answer is totally fine, but remember what's not is a decimal. Okay, and then last one from this set. So like I said, number 10, you're only going to be doing one of these 4 for the problem that you'll have on the test tomorrow, but I wanted you to practice them all. So plus or minus, big square root. And for the cosine one, the only difference is that instead of 1 minus cosine, it's 1 plus cosine. So this sign in the middle will just flip. So it'll be 1 plus a negative 15 over 17. Because remember, cosine is negative in this problem. Okay, so remember, my original angle was between 90 and 180. So half of my angle is between 45 and 90. So would cosine be positive or negative if I'm between 45 and 90? Positive. It's first quadrant, so it's still positive. So we just now know that it's the positive one. And if I multiply through by 17 again, the only thing that's going to change is this sign in the middle. So the only difference between this one and this one is just this little sign in the middle. The formulas are almost identical. So when I subtract, I get 2 over 34. And just like the one above, I can reduce that fraction down to 1 over 17 this time because I subtracted instead of adding. And simplify. Square root of 1 is 1. Square root of 17, we just leave it like that. And you can rationalize if you would like to. Okay, number 11, I asked you for tangent of 15 degrees. You could do it as 45 minus 30 and do one of the difference formulas, but I was expecting you to do it as a half angle formula. So 15 is half of 30. So you would set it up like that. So half of 30, because 15 is not on the unit circle, but 30 is. So if we look at this formula right here, we've got tangent of half of an angle. So the angle that we want to sub in is 30. So the 30 goes right here, which means the 30 goes right here and right here. Okay, so we copy down that formula. So it becomes plus or minus, big square root, and then we have 1 minus the cosine of 30 over 1 plus the cosine of 30. Okay, how do I figure out what the cosine of 30 is? What's that? Yep, off the circle. Pull them off the circle. So first of all, let's talk plus or minus. Where is 15 degrees? Quadrant 1. Is tangent positive or negative in quadrant 1? Positive. Everything's positive in quadrant 1. So I know it's going to be the positive version. So I have 1 minus, let's grab the cosine of 30. So here's 30, which means the cosine is the x value. And that's the square root of 3 over 2. So root 3 over 2. And then it's the same value in the denominator. Okay, so all we have to do is clean this up is what I did up above. And you want to clear out those fractions inside of fractions. So here you'd multiply top and bottom by what? 2, because this little denominator is 2. So you multiply everything. Remember, that includes the ones. Make sure you're actually distributing that 2. So big square root, 1 times 2, minus, and then with the fractions, the 2's will cancel, and all you'll have left is the square root of 3. And remember, none of these things cancel out. You can't cancel the root 3's, you can't cancel the 2's, because this has addition and subtraction in the middle. And as weird as this looks, you've got fractions with square roots under a bigger square root. That is actually the way that you leave it, because that's an exact answer, not an approximation. Okay, next let's look at number 12. And number 12 is more complicated than what I plan on giving you tomorrow, so I want to breeze through it really quickly just to see how you guys did on it. But like I said, it is more complicated. Okay, so what we do with this one is we actually start with the left-hand side, even though I know the right-hand side is the more complicated one, but we do this as a double angle formula. Okay, so instead of 2 theta, we're actually going to think of this left-hand side as 2 times 2 theta. So in that way, we're still using this formula right here. But then every time I have a theta, I'm actually going to replace it with 2 theta. Okay, so I'm kind of using this formula right here. Every theta is going to get replaced with 2 theta. So I have 2 times the sine of, and then instead of theta, I'm going to replace it with 2 theta, times the cosine of, and then instead of theta, replace it with 2 theta. Okay, so I just kind of subbed a 2 theta into this formula right here. Okay, because I used a 4 theta right here, which means these are going to become 2 thetas. Okay, and then the only other thing that I did is I took this, and you'll see that this is exactly what I have here, sine of 2 theta, so I'm just going to replace it with this. So I have the 2 that was already there, and then the sine of 2 theta, I'm going to replace it with this. So times 2 times sine times cosine. And then I'm just going to leave the cosine of 2 theta exactly the way it is. So you can actually see. So here's the right-hand side. You can see all the pieces. The 2 times 2 is what gives us the 4. And then we have the sine, the cosine, and the cosine of 2 theta. So all the pieces are there. So when you were multiplying, you can rearrange them if you need to. So that's 12. Like I said, I don't want you to like freak too much about something like number 12 because I'm not going to give you anything that complicated. So let's make sure we can get through 13, 14, 15, or hopefully at least 2 of them. So these are your 13-5 problems. This is when you solve using the unit circle. So first one, you've got cosine squared plus just cosine is equal to 0. So I've told you guys when you have a quadratic like this, you're going to solve by factoring, which means you need to move everything to one side, which it actually already is set up like that. You have a 0 on the right. So this is a factoring method that people forget about. It's the GCF. So these 2 terms have a GCF. They both have a factor of cosine. So you can factor out that cosine, and then you write your leftovers. So when you factor a cosine out of this, you're left with another copy of cosine. And then when you factor a cosine out of this, remember there is still a 1 behind. So you'd have a plus 1. It's not 0, it's 1. So once it's factored, you take your separate factors and you set them each equal to 0, like this. Okay, and then once you have either cosine or sine all by itself, that's when you pull values off the unit circle. So this cosine is already by itself. So let's make sure we get this one by itself. So subtract 1 over to the other side, and then cosine will be by itself. So we're going to use the unit circle and figure out where cosine is equal to 0 and where cosine is equal to -1. Okay, so I'm looking all around the unit circle. I'm looking at my x values. So anytime that cosine is either equal to 0 or -1, I want those angles. And I specifically told you to give me radians rather than degrees. So if we look around, here's 0. That's my first answer, so that would be pi over 2. Keep going, keep going. Here's -1, so that would be pi. Here's another 0, so that would be 3 pi over 2, and that's it. So if I'm looking at my x values for 0 or pi over 2, or I'm sorry, 0 or -1. So I had pi over 2 and 3 pi over 2 gave me a value of 0, and then pi gave me a value of 1. So I'm putting that in radians just because I told you to give the answers in radians. 14, we've got sine squared minus 2 sine equals -1. So this is a quadratic. So just like I mentioned with 13, you want to get everything on one side so that you can factor. So we're going to add this one over to the left. And then this one doesn't have a GCF. So this is going to be your classic 2 sets of parentheses to factor this down. So to get sine squared is my first term would be sine times sine. And then I'm supposed to be multiplying to +1, and I'm supposed to get a -2 in the middle. So that would be -1, -1. Okay, so I set both of my factors equal to 0, but both the factors are actually identical, so I don't have to repeat it. It's just going to give me the same answers. So get sine by itself by adding 1. So now I'm looking on the unit circle to where sine would be 1, +1. Okay, so sine is the y value. So this is the only place where I have a y value of 1. And I told you to give these ones in degrees. So this would just be 90. Theta equals 90 would be the only one. Okay, let me really quickly see if I can get this one in. This one is not quadratic, so you're not factoring. You're going to first subtract the -√3 and then divide by the 2. So we're looking for where cosine is equal to -√3/2, which if you pull the 2 values off the unit circle in radians, you end up with 2 values on the left-hand side that have an x coordinate of -√3/2. Okay, we just barely squeezed them in. 2 reminders for tomorrow. There's a review video on Edpuzzle. Everybody gets a note card. All right, 3x5 both sides. I will see you guys tomorrow. Yes.
Ian, wait up. Ian, wait up.
There you go, yep.
Good job.
See you later, guys.